let's have a look at the hyperbola, which is basically the same. It's just its eccentricity is different. But it still has all the same features. It still has foci. It still has directrices. I'm not going to derive the formula like I did the last one, but I could set it up the same and do all that. You will not be asked to derive all that, by the way. It's okay. We can just go ellipse is x squared on a squared plus y squared on b squared. But it is nice to see where it all comes from. Difference with the hyperbola is it's a minus instead of a plus. So x squared on a squared minus y squared on b squared is equal to 1. And so therefore, what happens here is b squared will equal a squared e squared minus 1. Remember, ellipse, it was 1 minus e squared. But that's all to do with the eccentricity. Right? So ellipse was smaller than 1, so you had to have 1 minus e squared to get a positive number. Hyperbola is greater than 1, so you need to have e squared minus 1 to get a positive number. So that little bit swaps around. If you make e squared the subject, again it's very similar, but this time it's a squared plus b squared on a squared. Again, because you need to get a number bigger than 1. So you need to add something to a squared, whereas in the ellipse you needed to get a number that was smaller than 1, so you subtracted the b squared. Foci still turn out to be the same, AE 0. The directrices still turn out to be the same. The position, however, is different because of the size of the eccentricity. So whereas with the ellipse, the directrix was on the outside of the focus compared to the origin, with the hyperbola, it'll be on the inside. And when you... Oh, yes, something the hyperbola has that, of course, the ellipse does not is its asymptotes. And the asymptotes turn out to be plus or minus b over ax. Okay? Because it's impossible for the curve y equals b over ax to intersect with our hyperbola. And you can prove that, if you like, by substituting in for the y value. You'll see you'll come up with an equation that's impossible to get an answer to. And there we are, drawing in the arc. So the positioning of the hyperbola is not what we're used to seeing. We're used to seeing, of course, like y equals 1 on x. But it is still a hyperbola. The difference is the vertex of the hyperbola is on the x-axis instead of, well, with our regular hyperbola, it's at the point 1, 1. So it's on the line y equals x. So basically it's been rotated 45 degrees. Now, it does not matter whether b is bigger than a or a is bigger than b for this one. What matters is which one is positive. So here it's the x squared's positive, so the foci is on the x-axis. If it was the y squared that's positive, then the foci will be on the y-axis. So y squared on b squared. So we'll see similar things happening now. Oh, okay, so the b's and a's, the x and the y's are swapping around. So instead of b squared equals a squared, e squared minus 1, we get a squared is b squared, e squared minus 1. Doesn't really change the eccentricity, if you think about it, because a squared plus b squared, except it'll be on b squared, won't it, instead of being on a squared, but it's still going to be a squared plus b squared on top. You're just swapping your a's and your b's around. Focus, 0 plus or minus be. Directrices, plus or minus b over e. Asymptotes do not change. It's still b over ax. So, we're going to find that this one, x squared on 9 minus y squared on 16 is 1. Same sort of thing then. Okay, a is 3. I'll work out my eccentricity. Turns out to be 5/3. So eccentricity is 5/3. Foci, a times e, plus or minus 5, 0. Directrices, a divided by e, plus or minus 9 on 5. In this case, we have asymptotes, so b on a, 4/3 x. That's really the only difference. Okay, so really the same ideas, and so I've just picked a couple out there to have a look at for the hyperbola.